This video is going to serve as an introduction to solving multi-step equations. So this shepherd right here, that's you. That's going to be our metaphor for solving multi-step equations. The first step is to break all your animals free. So right here we're going to have a variable m, and we'll think of that as monkeys. So over here we have some monkeys in cages, and over here we have some monkeys in cages. And our end goal is to find out how much one monkey weighs, the value of one monkey. So our first step is going to be get all the monkeys out of the cages so they're just roaming around the jungle and we can gather them up. So right here we have a 5 outside this parentheses. We're going to distribute the 5 to each of the terms inside. 5 times negative 2 is negative 10. 5 times 3 is 15. We have a subtraction sign, so minus 15. And then I'm just going to carry down the plus 17. On the other side of the equation, the right side, we're going to distribute this 4 as a negative 4 because there's a subtraction sign in front of it. So we can just think in our head that that's like adding negative 4. So we'll distribute negative 4 to negative 8, we get positive 32. Distribute negative 4 to negative 12. Again, when you see subtraction, you can just think in your head that's like adding a negative. So I'm just going to view this as adding negative 12. And I'm going to view this as adding negative 4. And negative 4 times negative 12 is positive 48. So two negatives make a positive. And then this minus 4 I'm going to carry down. That's step 1. All the monkeys are outside the cages. They're all roaming free. Step 2. Herd the animals on each side of the equation. So herding is combining like terms. And we're only looking still at each side of the equation separately. So we're going to look at the left side. What's going on in this jungle? We have negative 10 monkeys. There's no other monkeys, so that's fine. But we have two constants, negative 15 and positive 17. If we add those together, we get positive 2. So we're just simplifying each side now. On the right side, we have two constants, 68 and 48, which add to 116. And we have 32 monkeys plus negative 4 monkeys, which is 28 monkeys. So we've herded all the monkeys together on each side. Step 3. Use inverse operations to get all the animals on one side and all the numbers on the other side. So over here we have negative 10 monkeys. If I add 10 monkeys to both sides, these will cancel out because negative 10 plus 10 is 0. So we'll have no monkeys left on the left, and we'll have 38 on the right because 28 plus 10 is 38. Then with the numbers, we want all the numbers on the left, so we have this 116 on the right we're getting rid of. We're going to subtract 116 from both sides. On the right we have 0, so we're zeroing out this term. On the left we have 2 minus 116 is negative 114. And then the final step is solve the equation. We're going to divide negative 114 by 38, and that is 3, negative 3. So solution for m is negative 3. If we took negative 3 and plugged it in for m up at the top, or at any of these stages along the way, the equation would be balanced, it would work. So now let's do some practice problems. Right here, no cages. We can skip step 1. Step 2, combine like terms. Look at each side of the equation. Is there anything that can be simplified here? No. How about here? No. So we're going to go straight to step 3. Use inverse operations to get all the animals on one side. And for this problem, I'll go back to the top. We're going to want to subtract 5a from both sides. And that'll get us no alligators over here and 3 alligators on the right. Now we want to get all the numbers on the left, so we want to get rid of this plus 21. So let's subtract 21 from both sides. We get negative 9 because 21 minus 12 is 9. And we have 3a over here. Final step is divide both sides by 3. And we're going to get our answer, a equals negative 3. Now if we plug this in up here, it should work. Let's test it out. 5 times negative 3 is negative 15. 8 times negative 3 is negative 24. Negative 15 plus 12 is negative 3. Negative 24 plus 21 is negative 3. So it works. You can always test your solution by plugging it back in to your original equation. All right. Problem B. Here we have a cage. So whenever you see parentheses, think of that as a cage, and you need to break the animals free to make them easier to herd up. So we're going to distribute this negative 3. Negative 3 times negative 4 is 12. Negative 3 times negative 2 is 6. Over here, we have negative 10 minus 8. Next step. On each side, combine like terms. Here, no like terms, because this is a bison and this is just a regular 6. But over here, we do have like terms. These are both constants. So we can do negative 10 minus 8, which is negative 18. Next step is to get all the animals on one side and all the constants on the other. Well, here we only have one group of bison, 12 bison on the left. We have no bison on the right, so we don't have to worry about B. We just need to get rid of this plus 6. We're going to subtract 6 from both sides and get 12b equals negative 24. Then we're going to divide by 12 and get b equals negative 2. All right, letter C. Here we have two cages, right? So we have to distribute on both sides. On the left side, we get 20c minus 15. On the right side, we get 50c minus, let's see, 9 quarters is 1 quarter more than $2, so $2.25. Now we have to get all the caterpillars on one side and all the numbers on the other side. So you can have you face a choice here. We could either do minus 20c from both sides to get the caterpillars on the right, or we could do minus 50c from both sides to get the caterpillars on the left. I'm going to do minus 20c because I see that will leave me with a positive term on the right. So when these 20c's cancel out, it's important that this subtraction sign be brought down to acknowledge that this 15 is a negative 15. You can't just disappear this subtraction sign. You have to bring it down and make the 15 a negative 15 because that's what it is. On the right side you have 30c minus 225. Next step is to get all the numbers on the left side. And so we'll add 225 to both sides. That gets us 210. Final step, divide by 30, and we get c equals 70. All right, let's keep rolling. Letter D. We got a lot going on here. We have two cages on the left, so our first step, distribute the 8 and the negative 2. Remember, if there's subtraction in front of a number outside of parentheses, grab that subtraction sign and distribute it as a negative. So this D right here is like one dinosaur. It's a phantom 1. So we can do 8 times 1 is 8. And then we get 32. Over here we have minus 2d plus 2 equals 70 minus 3d. So there's a lot of things going on over here on this side of the jungle, because we have d terms which we can combine and we have constants which we can combine. So 8 minus 2 is 60, 32 plus 2 is 34. Now both sides are as simplified as they can get, so we have to start the process of getting all the dinos on one side and all the numbers on the other side. So we'll add 3d to both sides to cancel out the minus 3d. We get 9d plus 34 is 70. Then let's subtract 34 from both sides to get 9d equals 36. Divide by 9. Comes out to a nice whole number. D equals 4. All right, let's do two more. Letter E. One cage. Let's take care of it. Distribute this negative 7. We get negative 14 elephants minus 21. And now let's clean up the left side of the jungle. We have a negative 16 and a negative 21, which will come out to negative 37. Now let's add 14 elephants to both sides. And we have negative 37 is 23 plus 12e. Negative 2 plus 14 is 12. Now let's subtract 23 from both sides. And we get negative 60 equals 12e. Divide by 12. E equals negative 5. All right, final problem. Here we have one cage, so we need to distribute the 9. We get 9f minus 27 plus 3f equals 7f plus 43. We need to combine these flamingos. On this side of the lagoon, we get 12f minus 27 equals 7f plus 43. Now we're going to subtract 7 flamingos from both sides. We get 5f minus 27 equals 43. We're going to add 27 to both sides to get rid of that minus 27. We get 5f equals 70. We divide by 5, and we get f equals 14.